Alright, in this video we're going to do two examples of graphing rational functions. So the first function that we want to graph is x plus 2 over the quantity x plus 3 times x minus 1. So I like to collect a bunch of data before I start graphing, and the first thing I like to find is the zeros. So in this case that'll be negative 2, 0. So it's a factor of the numerator and not of the denominator, so that's got to be a 0. Next thing I look for is vertical asymptotes. So these are in the denominator and not in the numerator at this point, so x equals negative 3 and x equals 1 will work for us. Horizontal asymptote, in this case the degree of the numerator is less than the degree of the denominator, so the horizontal asymptote is going to be y equals 0. You could go through and do all the limits, which you should do if I tell you to show work, but your teacher might not require it. The next thing I'm going to do is find the y-intercept. So I'm substituting 0 in for x, I get negative 2/3. So now what I'm going to do is create a number line, and on the number line I'm going to test my regions. So remember, you're picking a number, you don't really care what the value is, you just care if it's positive or negative. So something less than negative 3, so negative a billion, would give me 3 negatives, which overall is negative. Negative 2.5 would give me 2 negatives and a positive. You just need to count up the negatives, which gives me a positive overall. You need an even number to get positive and an odd number to get negative, rather. If I pick 0, I would get the y-intercept, so I actually already know that this is negative, but I'll test it anyway. And then we can test like a trillion or something, and you definitely get positive. So I'm going to take all this information, I'm going to create my grid. So you can see I did the number line above it so that it fits perfectly. You might want to do that, it might not matter to you. I'm going to put in all of the asymptotes, and then I'm going to plot the points that I know. So I know negative 2, 0, and the y-intercept. Now what I'm doing is I'm thinking about the shapes that this can possibly have. So the y values are negative as you go to negative infinity, but it has a horizontal asymptote, so it's got to kind of hug the x-axis. And as you approach negative 3 from the right, it shoots down to negative infinity. So it's going to look like that on that region. As you approach negative 3 from the right, what's going to happen is that the y values are positive, and then it's going to hit the 0 at negative 2. So it's got to look like this. And then between negative 2 and 1, the y values are negative. I just have to make sure that I go through the y-intercept and then shoot down to negative infinity. So like that. And then finally, as I approach 1 from the right, the y values are positive, so it's going to shoot up to positive infinity. As I approach infinity, so as x gets bigger and bigger, the y values are always positive, but they're approaching 0. They're approaching the horizontal asymptote, so it's going to look like that. And that's a pretty decent graph of this function. If you take out your calculator and look at it, you'll see it looks basically like that. The only way you could really improve it is to find more points, but if you're really concerned about that, you should just be using a calculator to begin with. So let's take a look at one more. So here I have, it's kind of complicated, quantity x minus 1 squared times x plus 3 over x plus 1 times the quantity x minus 2 squared. So we will find the zeros. So if you do this enough, you just know what to do. So I have 1, 0, and then I have negative 3, 0. Now I'm going to look for the vertical asymptotes. So the vertical asymptotes are going to be x equals negative 1 and x equals 2. I'm going to look for the horizontal asymptote. So the degree of the numerator and denominator are the same. They're both third degree. And the leading coefficient of x cubed, or the coefficient of x cubed, is 1 in both cases. So the ratio is 1. And then I'm going to find the y-intercept. So the y-intercept is 0, 3/4. And now what I'll do is make my number line, and I like to indicate what's a 0 and what's a vertical asymptote. And I'm going to test regions again. So what I'm doing is you don't really need to look at the squared terms, because they're going to give you a positive no matter what you do. So I'm really just looking at what x plus 3 and what x plus 1 give me when I plug something in. So if I plug negative billion into those, I get a negative and a negative. 2 negatives give me a positive. Then I'm going to keep doing that. So I'm picking points, testing regions. You could just remember how these things alternate, but I prefer to just test all the regions. It's safer. Okay, so I have that. I'm going to take that and set up my grid. And then I will dot in all of the asymptotes. So don't forget the horizontal asymptote is y equals 1 in this case, which is not as common as for other things. Plot the points that we know. So we know 1, 0, negative 3, 0, and 0, 3/4. So I'm plotting those points, and now I'm just going to make sure the shape makes sense. So coming from negative infinity, the y values are positive, but as you go to negative infinity, you get closer and closer to 1, and then it hits 0 at negative 3. Between negative 3 and negative 1, the y values are negative, so it's going to shoot down to negative infinity. Coming from negative 1, the y values are positive, so it's going to start up at negative infinity. It's going to go through the y-intercept and hit that 0. As I go from 1 to 2, the y values are positive, so it's going to shoot back up to positive infinity. And then from 2 to infinity, it's always positive, and what's going to happen is it starts up at infinity and comes down, it approaches 1, so it'll look like that. If you take out your calculator and graph it, it's going to look a lot like that. So that's 2 examples of graphing rational functions, and I hope you found this helpful. Good luck.